It's often easiest to draw the circles first and then fit in the other points. Circle O is perpendicular to BC at point B. So I think my triangle is going to look something like this. Here's B, here's our right angle at C, and here is point A. The radius of a circle is perpendicular to the tangent line. So we have OB is perpendicular to BC. The coordinates of our three vertices, we'll put C at the origin. So B has a y coordinate of 6 and A has an x coordinate of 8. When we draw a segment from the center of our circle to the midpoint of chord AB, let's call this point M, it's not only the midpoint, but it's also the perpendicular bisector of chord AB. So we have OM is perpendicular to AB. The slope of AB is -3/4, which means the slope of OM is the negative reciprocal 4/3. The coordinates of M are easy to find, 4, 3. We'll use the point slope form of the line to find the equation for the line that contains segment OM. We'll use this equation to find the coordinates of the center of our circle O. Since OB is perpendicular to BC, O has the same y coordinate as B. In this case, the y coordinate of O is 6. Plugging it into our equation for the line, and we solve for x. X is 25/4, so the center of our circle is located at 25/4, 6. We'll repeat the same thing for circle P and then find the distance between the 2 points. This circle is tangent to AC at point A, so it's going to look something like this. The center of the circle, P, is directly above A, so it's going to share its x-coordinate. Drawing a segment from P to the midpoint of AB again, because AB is a chord of circle P, this is also going to be a perpendicular bisector, so it'll pass through the same point M. The line that contains PM is the same as the line that contains OM, so we can use the same equation. The x-coordinate of A is 8, and that's the same as the x-coordinate of P, so we will plug in x equals 8 into our equation to find the y-coordinate of P. Y is equal to 25/3. So our point P has coordinates 8, 25/3. Now we're going to use the distance formula to find the distance from O to P. Finding a common denominator, squaring our two terms and factoring out 49. Finding another common denominator, but not multiplying quite yet because we're going to take the square root anyway. By leaving it expressed in terms of its factors, it's easier to find the square root. This distance is equal to 35/12, which is option C.